Good day, everyone. My name is Abdullahi Garba Usman, and I'm here to present a very short topic on natural deputated solvents as a novel method in plant extraction for green and sustainable environment. In fact, this is the newest, the greenest, and in conclusion, I will conclude by saying it is the greener of the greenest solvents. This is the content of the presentation. And then in the introduction, deputated solvents were first introduced by Abbott and his group in the year 2003, which was named from the Greek word eutectics, meaning well melting. They reported interesting properties of eutectic mixtures of urea and a range of quaternary ammonium salts. In 2011, Baporte et al. Discovered that this existed in nature, and then they call it natural deputated solvents. They are widely used as a novel class of sustainable solvent that represent a green alternative to ionic liquids due to their cheapness and inexpensive. Due to the similar properties of gas and ionic liquids, that is non-volatility, non-flammability, high viscosity, and similar starting materials, these are sometimes referred to as the fourth generations of ionic liquids, though they are not entirely composed of ionic species. How are they synthesized? These are prepared simply by mixing two or three components, such as organic salts, normal salt we take in our food, ammonium or phosphonium salt, and a metal salt or hydrogen bond donor, in which there will be a kind of hydrogen bond between the hydrogen bond donor together with the choline chloride, for example. They will interact, and at first there will be a formation of hydrogen bond donor, and it will form the NADES, or natural deputated solvents. We need to define them. What are these natural deputated solvents? They are a combination of natural compounds, be it solid or liquid at room temperature. Chemical compounds that are in specific proportions, or they can be defined as solvents that have lower melting point than their individual components and are liquid at room temperature. Sources of natural deputated solvents. Though we are unaware until now that NADES are actually found everywhere. The famous examples are nectar and maple syrup. The role of NADES in plants, thanks to their specific polarity, they can be switched. They have tunable ability and tunable properties, protecting the plants against drought by retaining and absorbing water, protecting the plant against cold by avoiding crystallization of water at low temperature, enabling biosynthesis and storage of poorly water-soluble molecules. These are some of the examples of NADES, like choline, sugars, amines, polyalcohols, and carboxylic acids. Their advantages. Among the main advantages of these over ionic liquids are their lower environmental and economic impacts. They fully fit the principle of green chemistry and offer many advantages, including cost effectiveness, readily available components, simple preparation, and a lower toxicity profile. They show very good physicochemical properties such as negligible volatility, liquid state even at room temperature, that is at below 0 degrees Celsius, adjustable viscosity, wider polar range, high degree of solubilizing capacity and ability. And due to the above properties, it can be fine-tuned for specific properties due to their numerous application and structural possibilities. NADES are probably found in living cells and are involved in biosynthesis, solubilization, and storage of various poorly water-soluble metabolites and unstable compounds in cells. How can we design an independent research using this NADES? The following steps should be followed. First, select and fine-tune certain physicochemical properties of NADES. Then select and optimize the extraction method. Recovery of the target compounds from NADES, because it differs from one kind of NADES and the other, if necessary. This from the literature. According to the literature, phenolic compounds are studied the most as far as the last 10 years is concerned. In conclusion, based on the aforementioned extraction method, natural deputated solvent can be considered as the greener out of the green solvents, used especially based on environmental impact and cost effectiveness. The cost of NADES is comparably to conventional solvents, and their production could be classified as a sustainable process. However, to our current knowledge, there is no such process on the industrial scale, only on the micro extraction scale, that is on the laboratory researches. Though several other issues should be taken into consideration, which include the recovery of target compounds and or recyclability of NADES prior to the transfer of the methodology on larger scale. This is the reference of the presentation, and thank you for listening.